Hello everybody and welcome to this hands-on exercise for DPC++. My name is Stuart Adams and I'm a staff software engineer at CodePlay Software. I'm here to show you some of the work that my colleagues and I have contributed to the DPC++ project over the past few months. Before we get started, I want to be clear that these exercises will only work on Linux machines equipped with Nvidia GPUs. They will not work on Windows or the Windows subsystem for Linux. So if you want to follow along with me, you will need to move to a Linux environment with an Nvidia GPU installed. Familiarity with the C++ programming language will also be required to engage with these materials. To begin with, you will want to move over to the CodePlay Software GitHub and take a look at the Sickle for CUDA examples repository. Here you can find code samples and exercises that we are going to run through, as well as instructions on how to get them up and running. To work through our examples, we recommend that you install both Docker and the Nvidia Container Toolkit. These will help you run a container that has all of the libraries and environment variables needed to use DPC++ setup for you, which will make it a lot easier to engage with all of this. If you've not installed Docker or the toolkit before, we've included a link to a guide that will help you out. This only takes around 5 minutes to complete and install everything, so it's very handy. If you installed both Docker and the Nvidia Container Toolkit, then we can get started. So we're just going to run this command here, which will create a new container and we can run the examples within it. Okay, now that we're inside the container, we need to locate the directory that has the repo installed in it. And that is located at home examples and Sickle for CUDA examples. Great. Now that we're here, we're going to run through all of the examples included and then have a look at the exercise. So example 1 provides a implementation of a basic vector add for both Sickle and for CUDA. So having a look at this will give you a very good idea of the differences between the two APIs. So let's build this one. First, we're just going to make a new build directory, and then we are going to run Cmake. I recommend that you just copy this command here because we need to specify the Sickle root value, which just specifies where your Sickle implementation is located. So it's a good idea to just use the build commands that we have provided inside the readmes. Okay, now that Cmake is ran, we are going to run make. And you will be able to see that we now have two applications built, one for CUDA and one for Sickle. So now that we've got the basics out of the way, we can have a look at something a little bit more interesting. Example 2 shows how to interop from a Sickle application with an existing CUDA API. The API in question is cuBLAS, which is a linear algebra library that is built on top of CUDA. Here it's just calling the SGEM API, which I believe does a matrix-matrix multiplication. So we have two programs here, and you can just compare how to call cuBLAS from CUDA and how to call it from Sickle. The Sickle application makes use of some of the new interop features that we've introduced, such as the interop task here. Interop task just pulls out all of the native handles from the interop handler and then passes them directly to the cuBLAS API. So let's get this one building. Again, we're just going to make a new build directory and we're going to run the same cmake command as before. And now we can run make. And we will have our two applications ready to go. Great. Example 3 is really interesting as well because we are going to have a look at the vector add example again, but there is a twist. So the twist is that instead of using sickle kernels, we are going to use CUDA kernels now. So the code is still sickle, it's still setting up everything using the sickle API, but instead of writing a sickle kernel, we have this CUDA kernel here, and we can invoke this directly through an interrupt task. So to get this one building, all we need to do is to run make. Now the reason this one uses make instead of Cmake is because Cmake currently doesn't provide any way to change the CUDA compiler. Okay, we should have our two applications there, our vector add, and it works. So now hopefully after having a look at all of these examples, you will have a fairly good idea of the new interrupt features that we have introduced. And that means that we can have a look at the exercise. So just as example 2 showed how to interrupt from sickle with an existing CUDA API, exercise 1 encourages you to write one very similar. So example 2 has a sickle application that calls into cuBLAS and calls the sgem function. And exercise 1 wants you to do something very similar, but instead of calling sgem, it wants you to call sgemv. So we've provided a CUDA application which does the exact same thing, and we need to figure out how to adapt this CUDA code to sickle. So what you want to do here is to have a look at example 2, familiarize yourself with this code, and then look to see how that code was changed and adapted to work inside the sickle version. And just adapt that same logic and call sgemv instead of sgem. Now with all three of the examples working and the exercise, hopefully you have a much clearer understanding of DPC++ programming and how to interrupt between sickle and CUDA projects. If you need to ask any questions, we will be available in the DevMash Discord server to discuss both the exercises and the work we have completed on DPC++. This run through of the exercises has been recorded, so we will also post a link to a YouTube video, and that way you can easily rewind to follow the steps at your own pace. So thank you very much for watching, and I hope that you have learned more about DPC++.